Hello everyone, are you noticing anything different about me today? How about the perfect inflection, the flawless cadence to my words? Yes, that is right, I have gone robotic. Now, companies like 11 Labs offer a paid service, allowing you to transform text to speech on their servers with a paid account. And believe you me, that was the first thing I looked into when starting my channel. However, I just did not have the funds for it. So instead I just went with a microphone and my own voice. Now, however, I have learned just how easy it is to locally create your own sound files that actually sound human, well, human-ish. And in this video, we are going to cover just how easy it is to get set up with the latest free human product, the tts-blendr. A free app that uses Python to create WAV files from text files and allows you to easily blend multiple AI voices to get your own custom voice. We are going to cover the packages and the demo, but full disclosure, we are not covering much of the actual writing of the code in this video, mostly because the creator of this channel is a little self-conscious about his Python coding skills. Instead, this video is going to be more of a showcase of just how awesome and easy it is to provide professional narration to your videos. All right, let's roll the opening.
Wow! Okay, that intro you just heard, 100% AI generated, obviously. Now, it's not perfect, but comparing it to my own human voice, and it kind of seems like an upgrade. My favorite part, it was all free. And fear not, it can run on almost any hardware. And not just run, but run quickly. So meet kokoro-onnx. This is the secret sauce powering everything. The ONNX part is actually pretty cool. It stands for Open Neural Network Exchange. A fancy name, and all that it means is that this model, Kokoro, is optimized to run lightning fast on regular hardware. No $2,000 GPU required, no expensive cloud credits. Plus, it generates audio faster than I can even speak it. Local, private, and stupidly quick. To give you an idea of how easy this is, I want to go over an MVP version, the bare bones, required to get it working. Don't worry, I'll keep it fun. So for starters, when we do this, kokoro equals kokoro, and we're instantiating our class with those two parameters, the onnx file and the voices.json file. To keep the metaphor going, that's loading two things: the brain, the huge onnx model file with all the weights, and the personalities, the little JSON file full of voice vectors. The end result is not just a script triggering sound files like an old school TTS, it's voices as math. Everything, tone, pace, emotion, cadence, everything is converted to lists of numbers, aka vectors. And because the voices are math, we can then literally do algebra on them. So we're not layering audio files like in a traditional tracked audio program. We're blending their DNA. Further down in the example, you're going to see we're loading two voices, which are our personalities to draw from. Michael, who's super consistent, clean, and friendly, and Onnx, who's deep, crisp, a little gritty, and intense. And the real special part, the mixed style, is what makes it unique. Just like how you got some parts from both parents, our unique voice gets some numbers from each vector. Want it grittier? Crank up Onnx to 70%. Want it cleaner and faster? Lean harder on Michael. We pass this brand new mixed style into the engine and it invents a totally new person that has never before existed. Then we click run the script and we get the wave file spit out. Now, to really illustrate how powerful this is, I'm going to play the same text file first, not blended at all, and then 3 more times, each blended a little bit different way. And you can see how different it is just by blending it.
This is the moment where we test the pipeline. I am generating this audio on an Intel Mac using open source tools.
This is the moment where we test the pipeline. I am generating this audio on an Intel Mac using open source tools.
This is the moment where we test the pipeline. I am generating this audio on an Intel Mac using open source tools. This is the moment where we test the pipeline. I am generating this audio on an Intel Mac using open source tools. Starting off, we are looking at the source code for a Python TUI application I am building. I pop open the terminal here to test the current build. As you can see, it is technically functional, but the layout is not good. Everything is way too spaced out and it just feels clunky. From here, I jump into the Windsurf IDE to try and clean things up. I am writing a bunch of Python code here, specifically using the textual package to manage custom widgets and controls. I really wanted to tighten up that UI, but unfortunately Windsurf gets stuck here and actually ends up breaking the layout even more. At this point, I had to switch gears. We cut over to the cursor IDE, which I had actually been running in the background. Now you are seeing the good part, but truthfully, cursor got completely jammed up right before this. It took a solid few minutes to think through the problem, and I honestly almost gave up on it. What you are watching now is the model finally processing the instructions. I was asking it to rethink the entire visual hierarchy, which is why it hesitated for so long, but I edited out the wait time so we can see the result. It finishes the code, we open the terminal, and look at that. The new TUI is working perfectly and looks so much better. Now let's verify the functionality. First, I load up a text file as the input. Next, I need to select voice 1 and voice 2 from this drop-down list of available voices. Then we set the blend ratio. I am choosing a 60-40 split here from the options. I will quickly rename the output file and hit the Generate Audio button. We get a success message almost immediately. Finally, let's check the File Explorer. There is our new WAV file. I'll open that up in Audacity just to visually confirm, and yes, it looks like it generated the audio successfully. It really is that easy. I couldn't be happier with how this turned out and how easy it is to use. Here is the script for the outro, formatted for text-to-speech. In summation, I knew it was easy to generate an AI voice, but regarding video production, I could not commit to a service that charges per use. When you are making videos, you have to record and re-record constantly. Having a local AI model that I can use as much as I want is the only viable path for someone like me. The hardest part is actually writing the script with the exact amount of words to match the footage. It isn't necessarily more time-consuming than narrating it yourself, but a human narrator can speed up or slow down to hit their marks. That is something an AI voice simply cannot do. However, the AI voice is perfect every time. It is never going to stumble, say or have those vocal tics that can ruin a human recording. Every time I watch back one of my videos and count 16 I want to crawl into a hole. This method is a guaranteed way to eliminate that problem. Overall, I would really like to hear your feedback. You heard my real voice earlier in this video and now you are hearing the AI. What do you think? Should I keep the AI voice or stick to the human voice? For now, I plan to keep using the AI unless it gets absolutely hated on, in my honest opinion. It sounds really good, 1000% better than when I was recording with a cheap microphone. If you are interested in using Kokoro or the TUI app I created to make your own text-to-speech recordings, I have links to everything in the video description. The TUI app is on GitHub and available for download. It does have a few bugs, so if you are a Python developer and want to help clean it up, I would definitely welcome a pull request. That is about all I have for this video. Thanks for watching.